We're talking about inductive and deductive reasoning today. Inductive reasoning is the process of reasoning that a rule or statement is true because specific cases are true. It uses patterns to arrive at a conclusion, and that conclusion is called a conjecture. So some examples of inductive reasoning would be, every quiz has been easy, therefore the test will be easy. So because we've seen that in several circumstances the assessment's been easy, we're assuming that next one's going to be easy. We're making that conjecture. The teacher used PowerPoint in the last few classes, therefore the teacher will use PowerPoint tomorrow. We don't know the teacher's going to use PowerPoint tomorrow, but based on what we've seen the teacher using PowerPoint a lot. We're thinking there's a pretty good chance the teacher's going to use PowerPoint tomorrow. Every fall there have been hurricanes in the tropics, therefore there will be hurricanes in the tropics this coming fall. Again, you're picking up on a pattern. You're seeing specific cases that are true, and based on that you're making an educated guess. You're making a conjecture. And here's the definition of conjecture: a statement you believe to be true based on inductive reasoning. Conjectures are believed to be true but have not necessarily been proved to be true. So sometimes your conjecture could be a little bit off because it's not based on knowing for sure that that's the way it's going. You're doing that based on a pattern, based on specific cases. You're thinking this is a pretty good possibility. Alright, so example 1, write a conjecture and find the next two terms in the pattern. So we try to figure out what this pattern is, and it looks like it's increasing by 5 each time. So the conjecture might be each term is 5 more than the previous term. And so then if I continue with my conjecture, if I think that's the pattern that's happening, then I'm going to keep adding 5 more to each number. So the next two terms, if I add 5 to 7, that would give me 12. And if I add 5 to that, that would give me 17. So this is using inductive reasoning. We're looking at these specific cases, picking up a pattern, and coming up with a conjecture about what the next term should be. Alright, write a conjecture and find the next two terms in the pattern on example 2. So this is a straight angle, so that's 180 degrees. This is a right angle, which is 90 degrees. And right here we have a 45 degree angle. So we want 180, 90, 45. So the pattern you should see happening is that each angle's measure is half of the previous angle's measure. We're dividing the previous measure by 2 to get to the new angle. So each angle's measure is half of the previous angle's measure. So that's my conjecture. So based on that pattern that I picked up, based on this conjecture, what would the next two terms be? 45 divided by 2 is 22.5 degrees. So you'd have a 22.5 degree angle. And I'm not really worried about making my angle drawn to scale here. The number is going to tell me what the measure is. And then half of that would be 11.25 degrees. So I have an 11.25 degree angle. Alright, we've talked in a previous lesson about what a counterexample is. Counterexample is an example that proves that a conjecture or statement is false. So this is a little bit different definition than the one we've used before. Remember, for the counterexample to work, it's got to fit the hypothesis but not the conclusion. Okay? Alright, example 3. Prove that the conjecture is false by providing a counterexample. It says for all positive numbers n, 1 divided by n is less than or equal to n. So you could try a lot of different numbers. If I try a whole number, let's say I use 5, say it's going to be 5, 1/5 1 divided by 5 is less than or equal to 5. So 5 would be an example, not a counterexample. 5 fits this conjecture. Okay, if you use a negative number, let's say negative 2, that would make this a negative 1/2, and this is a negative 2. Well, negative 1/2 is not less than or equal to a negative 2. Negative 2 is smaller. Oh, I'm sorry. It said for all positive numbers, right? So I started using negative numbers, so that's not going to work. We need a number that's less than 1 then. We need a decimal. We need something that's less than 1. So if I use, say, 1/10, say 0.1. If I put 0.1 in for n, well, 1 divided by 0.1 would be 10. Is that less than or equal to what n was? Well, n was 0.1 based on what I just said. 10 is not less than or equal to 0.1, is it? So that is not true. So 0.1 is a good counterexample. 1/10 is a good counterexample for this statement. Alright, so far we've done inductive reasoning. Let's look at deductive reasoning. Deductive reasoning is the process of using facts, rules, definitions, or properties to arrive at a conclusion. The conclusion should be a fact. So remember, in inductive reasoning, we're picking up on patterns and we're making an educated guess. We're making a conjecture. With deductive reasoning, it's all based on facts, nothing but the facts. So your conclusion should be a fact. It shouldn't be an educated guess. It shouldn't be what you think it's going to be. It should be something that is known for sure. All right. Determine whether each conclusion uses inductive or deductive reasoning. So we're going to try to distinguish between the two here. A sign in the cafeteria says that a car wash is being held on the last Saturday of May. Tomorrow is the last Saturday of May. So Justin concludes that the car wash is tomorrow. These things that they gave us are facts. Okay, it tells us when the car wash is. We're talking about what tomorrow is on the calendar. These are facts. This is not just picking up a pattern or anything. These are facts, and that means this is deductive reasoning. So far, at the beginning of every Spanish class, the teacher has reviewed vocabulary. Spanish class is about to start, and Jamila assumes that they will first review vocabulary. No one's told her that they're reviewing vocabulary. She doesn't know for sure that they're reviewing vocabulary. She's basing this on past specific examples. She sees a pattern happening. This is what seems to always happen at the beginning of class, so I'm going to assume that this is what's going to happen next time. This is inductive reasoning. Alright, there are two valid forms of deductive reasoning. The law of detachment and the law of syllogism. So let's start with the law of detachment. It says, if P then Q is a true statement, and P is true, then Q is true. So, if I say, if we win the game, then we will go to the playoffs. So here's an if-then statement, conditional statement. This is if P, then Q, right? All right, if I know that this is a true statement, if I know that this if P, then Q is a true statement, and P is true, then Q is true. So if I know this statement is true, and then I know P is true, so what happens? We won the game. If I know both of these things at the same time, I know this is a true statement, and I know we won the game, then the conclusion is, based on the law of detachment, the conclusion is, if P is true, then Q is true. So the conclusion is, we will go to the playoffs. We are going to the playoffs. We are going to the playoffs. That's our conclusion. All right, determine if each conclusion is valid by the law of detachment. If you have $2, then you can buy a snack. So this is your if P, then Q. Then it says you have $2. Is that telling me that P is true? Yes. Then we can conclude that Q is true. Look at the conclusion. You can buy a snack. They're telling me Q is true. So I have a statement. I know P is true. They tell me the conclusion is Q is true. This is valid. Wow. Valid. All right, let's look at the next one. If you have $2, then you can buy a snack. So this is your if P, then Q. It says you can buy a snack. Now, remember, buying a snack is Q. And then it tries to conclude that you have $2. The law of detachment only works one direction. You got your if P, then Q statement. We have to know that P is true to conclude that Q is true. That's the only way the law of detachment works. It does not work the other way around. You cannot know that Q is true and then conclude P is true. That does not work. Okay? I know that if I have $2, I can buy a snack. But the fact that I can buy a snack doesn't mean I have $2. I might have $10. I don't know. But I do know that this statement only applies to the circumstance under which I know I have $2. If I don't know for sure that I have $2, this statement is not any use to me. The law of detachment only works if I know P is true, I can conclude Q is true. That's not what they gave me in this situation. This is invalid. All right, example 6. Give the appropriate conclusion based on the law of detachment. If you study, then you will pass. If P, then Q. So based on the law of detachment, if I know P is true, I can conclude Q is true. It says you studied. That means I know P is true. So my conclusion is Q is true. So I know, excuse me, I said I know you will pass. If you study, then you will pass. So if I know that if you studied, I can conclude you will pass. That's the law of detachment. All right, the law of syllogism says if P then Q and if Q then R are true statements, then if P then R is a true statement. So going back to my original conditional statement, if we win the game, then we will go to the playoffs. Now that's if P then Q. Now I need another statement, if Q then R. So notice the Q has to repeat. So Q was, we will go to the playoffs. So I need to start my next statement with that. If we go to the playoffs, let's say, then Jason Garrett will keep his job. So I got if P, then Q. And if Q, then R. Based on the law of syllogism, if I know that both of those are true statements, then we know that if P, then R would have to be a true statement. So the conclusion is, if P, then R. So P was we win the game. So if we win the game, then R. R was Jason Garrett will keep his job. So the law of syllogism is kind of like just cutting out the middleman. If P then Q, if Q then R. If this is all true, then I can skip that middle step and just say if P then R, because it's leading in these steps, P to Q to R. So we're just saying, well, then if P happens, R is going to happen. So if we win the game, we go to the playoffs. If we go to the playoffs, Jason Garrett keeps his job. So that means if we win the game, Jason Garrett's going to get to keep his job. All right, determine if each conclusion is valid by the law of syllogism. If you have a horse, then you have to feed it. If you have to feed a horse, then you have to wake up early. You have a horse. Conclusion, you have to wake up early. All right, so let's look at this. If P, then Q. If Q, notice it repeats. You have to feed the horse, Q, then R. So I got if P, then Q, if Q, then R. So then I should be able to come up with if P, then R as a true statement. So notice they tell me the P part is true. You have a horse, so I should be able to conclude R. You have to wake up early. So this is valid by the law of detachment. Okay, look at B. If a number is divisible by 4, then it is divisible by 2. If a number is even, then it is divisible by 2. The number is divisible by 4. Conclusion, the number is even. All right. If a number is divisible by 4, so there's P, then it is divisible by 2, Q. Now, this doesn't start off with the same thing this ended with. Q was divisible by 2, but it doesn't start with that. Notice the divisible by 2, the Q, is at the end of the second statement as well. This one we haven't used. The number is even, so that's got to be R. That's got to be a variable we haven't used yet. So we have if P then Q, if R then Q. That is not following the law of syllogism. We need that Q that is the conclusion of one statement to then be the hypothesis of the next statement. We do not have that scenario happening here. So this is not going to follow the law of syllogism. There's nothing that they're going to be able to give me next that's going to allow me to follow the law of syllogism to a conclusion. This is invalid. Alright, C. If you fly from Central to the Pacific time zone, then you gain 2 hours. If you fly from Texas to California, then you travel from the Central to Pacific time zone. You are flying from Texas to California. Conclusion, you gain 2 hours. Okay, one thing that's a little tricky on this one, they reordered things just a bit. What did you hear repeated before we got to this part? If you fly from the Central to Pacific time zone, then you gain 2 hours. If you fly from Texas to California, then you travel from the Central to Pacific time zone. The flying from Central to Pacific time zone is what is repeated, right? Well, remember in our law of syllogism, the one that's repeated is Q, right? Q comes up twice in that situation. So that's going to have to be Q if this is going to work. We don't know it's going to work yet, but it's going to have to. Okay? So this statement is actually the if P, then Q. And this statement is if Q, then R. So what they did was they just gave you what is typically the second sentence. They gave it to you as the first sentence. But all the same information is there. You have if P, then Q, and if Q, then R. They've given you what you need. Now, based on what we have right now, if we know P is true, then we'll know R is true, following the law of syllogism. So P was flying from Texas to California. It says you are flying from Texas to California. So they're telling us P is true. So therefore, we should be able to conclude that R is true. Remember, R was you gain 2 hours. Notice the conclusion is that you gain 2 hours. So while they reordered things just a little bit to try to confuse you, all the information is there. It does follow the law of syllogism. This is a valid statement. All right, last one. Give the appropriate conclusion based on the law of syllogism. If you are tired, then you need sleep. If you need sleep, then you will want a pillow. You are tired. What's the conclusion? All right, if you are tired, then you need sleep. If you need sleep, then you will want a pillow. So the sleep is repeated. That's your cue. If P, then Q. If Q, then R. It's even in the order that we like to hear it in. Okay? Based on law of syllogism, if I know these two statements are true, then if P, then R. P is you're tired. It says you're tired. Therefore, I can conclude R. R was you want a pillow. So I can conclude you want a pillow.